In this video, I'm going to demonstrate how to use uniTank to create floor layouts manually and automatically. This part of tank analysis comes after you have completed the floor settlement analysis, because you will use the outputs from this analysis to visually aid us in finding floor courses and plates. So first off, I will load in some of the outputs from the floor analysis. The three that I typically choose is the settlement, intensity, and standard deviation models. These three models give us three different pieces of information. The settlement model shows us the shape of the floor. The intensity model shows us the intensity returns from the scanner. And the standard deviation model shows us the data noise in the model. All three help us to identify where the floor courses and plates are. As an added bonus, the intensity model has a higher resolution than the other two. So when you are manually identifying floor courses and plates, this model will give you a higher horizontal accuracy than the others. If the plate lines are not clearly visible in one output, try looking at the other outputs. I'm going to first demonstrate the manual tools, because you may need these to repair the results from the automatic tools. So first off, I can identify the annular ring by entering the nominal height of the ring. The other alternative is to place a point where I see the annular ring and create the ring that way. Note that if you modify the annular ring, it will automatically delete all floor courses and plates, baselines, and annular plates you have previously defined. Next, I will identify the annular plates. Again, I can do this in two ways. The first is I can identify individual plate lines using the point tool. The other method is to estimate the plate length, place a point on a single plate line, and get uniTank to place plates at defined whole plate intervals. Now, I will define the floor baseline. This is the main direction that the floor courses run. If you define a new floor baseline, uniTank will automatically delete all your existing floor courses and plates because they are no longer valid. Once I have identified the floor baseline, I can now define floor courses. Again, I can do this in two ways. The first is I can identify individual course lines using the point tool. The other alternative is I can estimate the course height and get uniTank to place courses at the defined course intervals. Once this is completed, I can go and identify the floor plates. Again, I can do this in two ways. The first is I can identify every single floor plate in a course. Alternatively, I can identify a single plate line per course and get uniTank to place plates at defined plate intervals. This tank has an irregular gridding at the top and bottom, So I will delete the floor courses at these locations and manually insert floor plates. The floor plate tool will allow you to create parallel or perpendicular lines and will automatically intersect them with existing floor plates and courses. Lastly, if you have additional items to delineate such as column repads or patch plates, you can use the polygon, circle, or rectangle tools to delineate them. Then you can create them as floor outlines. Now you know how to use all the manual floor layout tools, we will see how we can do this automatically. The automatic tools use the point data to find the floor courses and plates, so the models we loaded before are for visual reference only. However, they will assist us in knowing which component of the data to use, the geometries or the standard deviations. If you see something is more clearly visible in the standard deviation images, select standard deviations as a source. Otherwise, select geometry as the source of detection. If the data source you are using is fairly noisy, you can choose to smooth the data to see if it improves the results. With auto detection, you can change the horizontal accuracy of the results by modifying the resolution. Typically, we can get to 1-inch accuracy. However, for noisy datasets or datasets where the trends are not clearly visible, using a higher value for resolution, such as 2 inches, will yield more stable results. The last two options for this dialog are the filtering thresholds used internally. The first is the edge detection threshold. Think of this as the true positive filter. This is the threshold at which uniTank decides if a pixel is an edge pixel or not. Increasing this number will decrease the number of edge pixels it finds. Decreasing this number will increase the number of edge pixels it finds. However, if you find too many edge pixels, the positional accuracy of your lines will start to degrade. The line detection threshold is how many edge pixels are needed to form a line. Think of this as your false positive filter. The lower the value, the fewer the number of pixels required to form a line. The higher the value, the more number of edge pixels required to form a line, thus reducing false positives. So if you want to play around with these settings, set the line detection threshold to 0. Then adjust the edge detection threshold until you get all the true positives you are looking for without getting too many false positives. Then adjust the line detection threshold until you remove as many false positives without starting to remove your true positives. But to start off, let's just leave the values where they are. So I'm going to use the detection tool to first find the annular ring. It is very difficult to detect annular plates in the point data, so I will show you how to use the tool locally. As with all the different layout types, if we create a selection around an area, it will look for that layout type only in that area. If we want to look for layout types globally, make sure nothing is selected. Once we have the annular ring defined, we need to manually define the floor baseline as before. But once we have done that, the rest is pretty easy and automated. As before, I'm going to delete the course at the bottom because this tank has an irregular plate layout at the top and the bottom of the floor. As well, I am going to ensure that we have picked up all the floor courses that we need. So if we are missing some, I can go select an isolated area and automatically detect the floor course in that location. If you find the system is finding too many false positives, one other way to limit those false positives is by increasing the minimum plate size. However, for this tank, I know that there are several small width plates, so I'm going to leave this parameter at 2 feet for now. As I go through the results, I will delete false plates and add plates where they're missing. I can use the localized detect function to find these missing plates. Sometimes I have to switch between the standard deviation or the geometry source in order to find the plate, as it is sometimes visible in one output but not the other. You can use the shortcut key Shift-Delete to quickly delete what's selected. When you are satisfied with the layout, create the plates. You can choose numeric numbering or coarse plate style numbering. You can also choose to number from the northwest corner, southeast corner, or left to right. Once you are satisfied with the plate numbering, you can export the plate layouts to a graph, CAD-compatible DXF files, or Excel-compatible CSV files. uniTank automatically calculates all the plate positions and dimensions for you.